Unit 3, Scatter Plots and Bivariates. We're working with outliers and influential observations today. Objectives. The students will be able to create scatter plots from given sets of bivariate data and determine if there are points in the data set that are outliers or influential observations. The students will be able to calculate the correlation coefficient for a given set of bivariate data. We already know how to do that. The students will be able to calculate the linear regression line for a given set of bivariate data, which we already know how to do as well. So outliers and influential observations. Outlier, a data value that weakens the correlation. The Y value doesn't fit. Notice those 2 points that are circled. Those would be outliers. They have a major vertical difference. Influential observation, on the other hand, is a data value that strengthens the correlation. There's a major horizontal difference. Notice the point over there. It is pretty much in line with the trend of the data so far. So this point is within the original pattern of the data, but much farther away. That is going to strengthen the correlation coefficient. Outliers and influential observation. Let's look at this first one. I've put an oval around the data that suggests the general trend, and this point is outside of that, and it could be an outlier. It's unusually high for that area of the oval. Now this one right here, that's the general trend of the data, but this point is way over. Yes, it is far over to the right, but it's not in line with the original trend of the data. So that's an outlier as well. Same thing with this. And this would even have a higher correlation coefficient without that outlier, because the data isn't as scattered in this plot as the one prior to it. Here is a general trend of the data, not including this in the curve, but that's an influential observation that is going to strengthen the correlation coefficient. More with outliers and influential observations. Look at that data point there and the general trend of the data. This point, when added to the data, is going to weaken the correlation coefficient because it's an outlier. If this point was removed, then it would strengthen the correlation coefficient. There's another point that is not in the general trend of the data, so that is also an outlier. Same thing with this one right here. It's not in the general trend of the data, so that would definitely alter the linear regression equation and the strength of the correlation coefficient. Now look at that point. It is within or in line with the general trend of the data. So this point, an influential observation, when removed from the other data points, is going to weaken the correlation coefficient. But if it's added to, like it is right now, to the other data points, it's going to strengthen the correlation coefficient. A point along the same pattern or trend as the rest of the data that is distant from the rest of the data points is definitely going to influence the correlation coefficient. What are outliers in scatter plots? So consider the scatter plot to the right, which shows data for students on a backpacking trip. Each point represents a student. Notice how 2 of the points don't fit the pattern very well. These points have been labeled Brad and Sharon, which are the names of the students they represent. Now Sharon, the one up at the top, could be considered an outlier because she's carrying a much heavier backpack than the pattern predicts. Brad could be considered an outlier because he is carrying a much lighter backpack than the pattern predicts. Outlier problem number 1, computer shopping. Michelle was researching different computers to buy for college. She looked up the prices and quality ratings for a sample of computers. Her data is shown in the scatter plot to the right, where each point is a computer. Michelle wants to buy a computer whose quality rating is far higher than the pattern would predict. So price was along the x-axis and quality rating is on the y-axis. So we're looking for a point that has the lower price but higher rating. Which of the labeled points represents a computer that Michelle wants to buy? And of course, this is going to be point B up there to the left. Here's another one. This is number 2, test scores. There's a plot there. Some high school students in the U.S. take a test called the SAT. You know that, before applying to colleges. Scatter plot at the right shows what percent of each state's college-bound graduates took the SAT, old data, in 2009 to 2010, along with the state's average score on the math section. Now, Michigan doesn't give the SAT very much, so the participation percentage would be lower, so they'd be over on, more the right-hand side of those scatters. 3 labeled points could be considered outliers. So I made them blue so it's easier to see. Why might these points be considered outliers? Option A, these states scored lower than other states with similar participation rates. Or B, these states scored higher than other states with similar participation rates. They're lower on the graph, so that's going to be A. Here we go, and the Google form is similar to this. So in list 1, put in the X values. This is a very small data set, but go ahead and do that, please. 2, 5, 6, and 8. In list 2, put in 45, 51, 60, and 58. So we have 4 data points. Not much of a scatter plot with only 4 points, but we can do our linear regression. I want you to give me the equation just for practice, but it's the correlation coefficient that's important. That's the R value. We round those to 3, so 0.885. Linear regression equation, go to 3 points, or 3 decimal points as well. Of course, B stops at 2. Now let's add to the data set another point, 25, 100. So just at the bottom of list 1 and list 2, add the 25 and the 100. And that's what the new scatter plot's going to look like. That is an unusual value. If we do our linear regression, the R value is now stronger than it was without that data point. It's now 0.992. There's our linear regression equation using the A and the B just for practice. So is the correlation strengthened or weakened, and classify the data value? So based on the original, and we're always going to compare to the original, which is the top there, the 0.992 is higher than that, so it strengthened the correlation, so it's an influential observation. Now we're going to remove the point 25, 100 and replace it with 412. Here's our new scatter plot. There's the value that we added to it. Notice how much further down it is than the other ones. We do our linear regression, and wow, there's our R value this time, 0.499. Linear regression equation changes as well, and we're doing that just for practice. So we're comparing it to the top, 0.885, and 0.499 is definitely lower. So the correlation was weakened, so that point is an outlier. Okay, old data, we used to do a project with this. So I actually took all this from an Excel file because they did activities using Excel. That's back when we had to borrow a class set of computers because not all the students had it. Okay, so anyways, there it is. That point is unusual, and look at it has the linear equation line with that point in it. It doesn't follow the other points. And that point is that one right there. Regression analysis. So there is the data with everything they gave us off to the left. And here is the linear regression equation and our R value. So the R value for original data is 0.8214. I must have had them go to 4 places. It's not in the directions. Sorry, I should probably add that. Now remove that top 2 values. The X value is for the one that is very unusual. So we're taking out the 534. You can be on it and push delete. And then go over to the 4,375, be on that and push delete, and they should be gone. So we remove that from the original data, and that gives us an R value that is stronger. So the data for that aircraft, the 474-400, would be classified as an outlier because the correlation coefficient was strengthened when that value was removed. Here's another one. This time we're looking at flight length and aircraft operating costs. Sorry, I didn't even read what the X and the Y axis were representing in that last one. Oops. Okay, but there is a value that is unusual. And of course, it's that first one there, the B474-400. Same aircraft is the last situation. So a regression analysis, okay, there we are. That is the strength of the correlation with that unusual value included. But what if we take it out? So we remove it again. So go to your list and take out the 4,375 at the top of list 1 and the 7,098 at the top of list 2. And you should have those values there in the pink. When we do our regression analysis with the linear regression equation this time, this is the R value. It did decrease. It's an influential observation because the correlation coefficient weakened when that unusual value was removed. Make sure you do your assignments.